Thank you. So I'm Toni. I'm a PhD candidate at the University of Heidelberg. And I want to start by a very brief introduction of the kind of science that we do. So basically, we have these large-scale simulations where what we try to do is to take a very early initial conditions of the universe and let them evolve in the simulation for about 13 billion years and hope that the result we get looks anything like our actual universe that we live in. In particular, what I'm interested in, and this is something that's been mentioned in the first talk today by Chris, is so-called reionization. Very briefly, reionization is a phase that the universe went through approximately like a couple of 100 million years after the formation, where almost all the hydrogen in the universe went from being neutral to being ionized. And in order to understand this, during the last year or so, I've had the pleasure of writing an HPC code in Rust from scratch, basically. And the basic question that this code tries to answer is, if we take one of the snapshots, one of these outputs of the simulations, and we suddenly let all the stars and all the galaxies emit light, then how would reionization take place in our toy simulated universe? I won't go into any detail of how this actually works. It's an HPC code, and I've run it on a couple of thousand cores by now. I'm not near the actual production runs, but it seems to be working fine so far. What I wanted to talk about very briefly are two of my kind of highlights out of the many things that I really liked about developing this kind of code in Rust. And the first thing is memory safety. Now, this is kind of the main selling point of Rust, so it seems kind of dumb to put this here, but I think maybe to some people, especially if you come from non-systems languages, like if you come from Python, for example, maybe it could be a bit hard to appreciate what memory safety actually does for you. And so what I wanted to do is give you a short example of something that I encountered when I wrote a similar algorithm previously in C. And in this C code, I had a bug that happened only when I ran with more than 500 cores for some reason. And it also happened only very rarely. So I had to rerun it, and debugging this thing was a nightmare. It took me about a month to finally pinpoint what is going on. And well, the answer was, okay, I'm just not a good C programmer, but it's also a bit of a pitfall. So what I tried to do, this is an MPI code, and I wanted to send a message between two MPI ranks, which, if you don't know MPI, those are basically threads. And in particular, I wanted to do MPI isend, which sends a message and it immediately returns. So it allows me to continue doing any kind of computation without having to wait for the other rank to receive my message. Now, in C, MPI, it is your responsibility as the programmer to make sure that you don't modify, or in this case, free the message buffer in any way before the other rank has received the message. Now, it happened that in my code, I did this in some of the control flow. It could happen that I freed this before, and this caused the bug. So of course, when I rewrote the same part of the code in Rust, I asked myself, okay, how does this compare? And here, I think the cool thing is that if you write Rust with the RSMPI library, then, well, the equivalent method to isend is immediate send. And the way this is set up is, if I call this, it gives me some kind of request object. And this request object is two things. First of all, it allows me to ask the other rank whether it's received the message. Well, that's nice. But crucially, it also panics when it's dropped. So when it's dropped and the message hasn't been received by the other rank. And why this is important is because the way this function signature is set up requires the message to live at least as long or longer than this request object. So this means either your send actually completes and you ask the other rank whether the send has been completed, or your code panics, but you never get undefined behavior this way. If you try to fool the compiler somehow and move this message into here so that it could potentially be dropped before the request, then you'll get a compile error. So this is impossible to write in this way. So this is one thing that I found very nice. Another thing I wanted to very briefly mention is so-called compile time units libraries. So the basic idea here is that instead of having all kinds of anonymous floats in your code, you annotate those floats with actual types that represent physical quantities. The basic idea being, if you make a mistake somewhere and you change this formula to be invalid, the compiler will tell you, this is not a valid formula, what are you doing? Since I'm sloppy, this has prevented countless bugs for me. And it's also, I think, just in general, much nicer to read code this way than to have this representation as these floats, which I don't know what they do. For this purpose, I wrote my own library to do this that uses the const generics feature. And so it's unstable. It's also, I think it's very nice. I've used it for quite a while, but it's not even remotely as mature as these other libraries, such as units of measurement or dimension. So if you're interested in this kind of stuff, I totally recommend using compile time libraries. I should mention that this comes at 0 cost overhead. So after compilation, this reduces to just floats and you pay no price for this. So that's it from my side. Thank you.
All right, thank you very much. Yeah, I think it's very nice to see such a concrete example of how Rust memory safety can really aid MPI, for example. So that's a very nice, neat little example. Right, do we have any? I think there's not yet a question in chat. This might still appear. I can maybe ask one quick question. I just saw, you had this MPI send. I just thought for these kind of things, I haven't used much MPI in Rust myself, but do you think, like, for example, async could play a role in MPI in Rust? I'm not sure if this is developed already or if you think this could make some sense when you have this.
Can you repeat again? What do you mean?
If the async, like asynchronous programming with features and so on, do you think this could play a role in using MPI together with Rust?
I don't want to say because I'm not an expert. Maybe somebody could build a library around this. Like from what I understand right now, MPI is basically just a wrapper around whichever the C implementation you have. And I guess you could write any kind of wrapper around that. So not in my place to say. It would be wonderful if there was a bit more of a convenient framework for MPI, even though, like, compared to C MPI, it doesn't compare. It's so much more convenient. So I'm not sure.